My daughter is watching the live stream from home. So, okay. So, hello everyone. I want to start my presentation with introducing myself. I'm Soutaro Matsumoto. I hope that everyone here knows what is Steve and RBS. I developed them. And yeah, I'm one of the Ruby committers, and I'm working for Block. The company was renamed from Square last year. I think that I like the new name because that some people confused the company name, the company I'm working for, with Shopify or Stripe. So I think that there are too many S things in this area: Shopify, Stripe, Solve, Square, Steep, Soutaro, maybe Sega. So anyway. This year, we have 5 talks related to RBS and Steep. It is really amazing to me. It was really great experience to watch the live streaming from my home, that people are talking about RBS or Steep. It was really great. But that one thing I'm not feeling very happy is that most of the talks, the 3 of the 4 talks are generating RBS. I know it is a really important topic, but that I want to focus more on how can we use the type definitions. Kirby had a presentation about using the method types of the RBS signatures instead of callsec in RDoc. It's great, but I want to talk about using the type information to read or write the Ruby code, so type checking. Before going to my talk, I want to quickly introduce the latest version of RBS. It is 2.7.1. So it is not it is an pre-released gem, so you need the --pre option to install that. The new feature of 2.7 is it supports the declaring the type of the self in blocks or procs. So there are 2 method definitions here. Foo method, the method receives a block, and the square bracket is to specify the type of self inside block. So in the foo method, the self is string inside block. This is especially useful for instance eval, the type of instance eval. The first self is keyword, and the second self is the type of the receiver. RBS 2.5 was released 2 months ago. It ships with a batch prototype feature. It is an RBS prototype RB. If you specify the out dir option, it will scan all of the RBS files in the app directory, and it will generate the RBS files in the sig/app directory. Another feature I want to introduce is RDoc plugin. So it ships with an RDoc plugin. So this is a project supported by Google Summer of Code, and I'm mentoring one student, and he implemented this one. So it will generate the RDoc documentation from RBS files. Instead of from the RB files, it scans the RBS files, and it detects the class definitions, module definitions, method definitions, and make an RDoc output. So I want to start introducing the benefits of type checking. When we have a typed Ruby code means a Ruby code base that is type checked with Steep or some type checkers they have some RBS definitions of each class, each method, each modules. So it will help you understanding code. The RBS files works as an API documentation. So when you add some new feature, it will help you writing the Ruby code, or refactoring will be somewhat easier. And I want to start the demonstration. I want to show the Ruby project with type definitions, and I want to demonstrate how the hover go-to definition, completion, or detecting type errors works. Oh no, I'm sorry. So this is Ruby code. This is order.rb. So imagine we have something like the POS system. We have the order.rbs file. So it has the method definition. So it has some each payment method. So if we hover the each payment method definition, it will display the method signatures, and when we point the block, it will show the type of block, local variable. The completion also works. There are some card payments. This is an association, and it is a method. So card payments. So these are Rails active record methods. So, and then we can do the where select, anything that defined methods on that class. Jump to definition is somewhat supported. So if we forward the constant, it shows the sum of the class definition of that constant, and then we can go to definition, and then we can jump to the RBS file. We can go back to the Ruby code from the RBS definition. So click the total method, and then click the go to definition, and then it jumps to the definition of the method. If we have some string here, it will report an type error because the gross is an integer, and there is no plus method between the integer and string. So this is a quick demonstration of how we can use the IDE if we have RBS definitions. And the next step is that next demonstration is how can we get started with Steep. So setting up the gems or generating RBS file prototypes, running type checkers, and we can add some types. So this is an explanation of the demo application. Assume that we have point of sale feature. So we have 4 modules. Order is some module. It corresponds to a receipt. And we have the order item module. It is the items you get from the shop. And another one is cash payment and account payments. So this object is to represent the monies you give to the shop. Okay. The first step is to edit the gem file. We will add some setup. We add some gems here. So steep, RBS, and RBS Rails. We don't have to add RBS, but I want to use the pre-release version here, so we need that one. And let's bundle install. And everything will be installed. Now, okay, it's not working. Come on, yeah, okay. So we have steep 111. It's the latest release version. So I want to have a bin steep command to execute this steep. And I need to RBS collection init is to create the RBS collection YAML. The file is to declare the dependencies to the RBS libraries. Some gems have RBS files of their classes, but here we write some of the list of the okay. So in this case, that we don't need the RBS type signature of RBS gem itself or steep itself, RBS Rails itself. So we add the ignorance. And then run the RBS collection install. So it will download the RBS files from the gem RBS collection repository, and it takes some time. Okay, so let's stop doing this. And move to another branch. So we need to do some setup to install the gem RBS collection and steep or like that. And please read the documentation of each repository. So we can go to the next. We can install the RBS Rails break tasks and generate the RBS files of the database modules. We have the string directory here and have some RBS files of each modules. So these modules are generated from the runtime information of the active record. So active record modules have some methods of each attribute, and the method definitions of that module, that methods are generated. And okay, then let's try running the steep check right now. Okay, I don't have bin steep. So I forgot to add the steep file. It is a configuration of the steep. So we will define app target. Target is some unit of the configuration to type check. And now we run steep check. And what is happening? RBS correction install. Why we need that? Okay, unfortunately, it doesn't work at all, so... Oh no. Okay, so I want to skip the demonstration of this part. Come on. Okay. I'm really sorry that I have to skip some part of the demo. Okay, so I was planning to show how we can start type checking the existing Ruby code. So we have some Ruby code, it's running Ruby code, and we generate some prototype of RBS files and edit some RBS files. And yeah, we will find some problems and fix that or like that. But okay, after that, we skip the demonstration and go back to the presentation. I wanted to say that we have to focus on the part you work on. You don't have to fix all of the type errors when you start type checking. So you will work some part of the Ruby code to add new feature or to fix something. Then you write the RBS type definitions at that time. So this is an example that this is the result of a steep check of the steep repository itself. So you will read that there are more than 1,700 problems are left in steep. And in fact, we have more than 2,000 type errors in the steep repository. But I'm good for writing new code with the type checker's assistance. Another thing is that to make your code safe against new. It is the only way to handle new safely is to test every time before using the value. Optional type is for it. So we can do something if that is new, or we can tell Steve that it cannot happen. And we sometimes need to write some inline type annotations to help Steve understand your code. We sometimes need to declare some of the type of some variables, or we need some inline annotations to support metaprogramming, or the casting or skipping the type checking is the last way. So then I want to explain that how we can write new code using the type checkers. I found that type checking the existing Ruby code is not very good experience, because you know that there are no critical bugs there. You already tested that, your teammate reviewed that, or it is already running on the production. Steve will detect some minor problems, but it doesn't make much sense. It just requires you add some workaround, some inline annotations in cast or like that. It means that it requires too many effort for too little benefits. So instead, I think that writing new code is more fruitful. There must be some unknown bugs. And this is the demo 3. I want to add some feature to the demo app. And I want to show how I can define the APIs in RBS. And I want to show that writing the implementation with type checker will be Yeah. So I want to add some feature to search the orders. So we put some name of the items cafe latte, or we want to add some features to do some filtering before some day, sometime, or we can filter that if the order is paid by some cash or card, like that. I want to call that the class search service. So this is the smallest implementation. So we have the name. It is the name of item. So the initializer receives the name, and then we will construct some queries receiving the relation of orders, and it returns on order. The implementation will look like the, okay, jump to definition. Oh no, why? The implementation will look like this. So yeah, this is stupid implementation, but it should work. I want to support some other types of the queries. So add a module called query and some classes. It has the name, it is string. This is the copyrighted, the name of the items. And we will add some classes for before and paid by card or paid by cash. So these are the classes to represent each clause of the query. And I want to define name and before, paid by card, paid by cash. And there will be a parse method. It translates the string to array of T. T is this one, name or before or paid by card or paid by cash. And this will be an queries array of query. So, okay, this is the RBS type definition of the search service features. Okay, so let's do some implementation. Editor reader queries, it will be queries, and it will be, we will have the, so orders is, oh no, the order object. So we use the inject, and we write some case when query by name, querying by before, querying by card, by cash. And yeah, we will implement these ones. So the name query has a name attribute, and okay, let's skip the before query. How is the paid by card? So it would be, you can do that with the, oh no, joins. So this is the implementation of search method. Okay, so this is how I'm using the type checkers. You may find that I was using the union types instead of the inheritance. I think that you feel like adding some base class to the base class and add some methods, something like the build relation would be the better. But that we can do that the almost equivalent with union types. We have the union type of query, name query before query or like that. And then we do the case when to do the case analysis. So there are two styles. The first one is the using inheritance and method calls. The second one is the union types and case when. You can choose the one of them to write some implementation. I think that you will decide that, but some of the rules, if you have the known set of the data types, in this case, we have the 4 types of queries. And then we can use the union types and case when. If you don't have the specific set of the data types, it happens that you provide some libraries and you expect the application inherits some class from your library. So in this case, the inheritance and method call is better. This is something related to the expression problem. This is old problem. And union types are generalization of optional types. Integer question, this is an optional type. It is equivalent to integer or new. This is union type. And the steep and the type checkers will help you enumerate all cases of the union types. So if you add a new case to the union type, the type checker will detect the case analysis is not exhaustive, and you can fix that. And this is a small diagram of the working with types. So we have some kind of the concepts, application code, tests, RBS, and design doc or whiteboards. The right is more abstract, left is more detailed. RBS type definition is between the test and the design docs. So it's more abstract. So it is easier to change or write the type definitions compared to writing the implementation or tests. And another one is that writing types and writing code is not one-way direction. So we write some types, then write some code, found some problems and fix types, change the code. So we back and forth between the application code and type definitions. I showed it with Steep, but you can try it with RubyMine. RubyMine has limited support for Steep, but it provides their own type checkers. It is integrated with RBS, so you can write RBS types, and then RubyMine will type check your Ruby code. So I planned to do some demonstration, but it didn't work very well. So I want to say that you will get more benefit from types when you write new code. If you type check your existing code, it is not very good experience, but that I believe that when you write new code, it will help. It will be really helpful. And another one is writing types and implementations. Some anti-patterns, writing the case when without type checking can be best practice if we have some type checkers. Or the writing types is easier to try and errors to find the best APIs. So yeah, it will help you making your program. So this is everything I have today. So thank you for listening.